Welcome back. This is an Aleks training video on recognizing common acids and bases. So if you remember from a previous lesson, we had strong acids and strong bases. So strong acids, anything that's not on the list of strong acids and strong bases are weak acids and weak bases. So we're going to have 7, I think I said 6 before, there's 7. You're going to have the 3 in group 7. So you're going to have HCl. So not fluorine, but the next 3: HCl, Br, and Hi. So if you remember, single elements that are acids need hydro. So it's hydrochloric acid, hydrobromic acid, hydroiodic acid. You're also going to have 2 from the chlorate group. Okay, so you're going to have hydrogen chlorate, because this is hydrogen chlorate, which is chloric acid. So it's chlorate, hydrogen chlorate would be chloric acid. And then the next one above that, which is ClO4, which is perchloric acid. Right? Now, 2 more. You're going to have HNO3, which is hydrogen nitrate, nitric acid. And then the last one is hydrogen sulfate, which is sulfuric acid. Anything that's not on that list is a weak acid. Okay, if it's got a hydrogen to give, you can see all these hydrogens out front. If it's got a hydrogen to give, it's an acid. If it's on this list, it's a strong acid. If it's not on this list, it's a weak acid. The strong bases are all hydroxides, which really makes it easy, and it's from group 1 and group 2. So if you're looking at a periodic table, you're going to go down the side. Now, lithium doesn't count. It's just going to be, and francium doesn't count. So it's in group 1, it's everything except hydrogen and lithium, or sorry, hydrogen and francium. So it'd be lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, and cesium hydroxide. Okay, so let me look it up to make sure. Lithium, sodium, potassium, rubidium, cesium. Okay, that's all group 1s. And in group 2, there's just 3. They're the heavier ones. So you're not, beside lithium is beryllium, it's not 1. Beside sodium is magnesium, it's not 1. It's these 3. So calcium hydroxide. Now calcium is 2+, so I need 2 of these, calcium. And then beside rubidium is strontium. Strontium, and then beside cesium is barium. Okay, so here's the list of strong bases. Here's strong acids. And if you remember, strong acid doesn't mean it's more corrosive. Strong acid means it completely breaks apart into ions in water. And this is strong bases. Okay. Anything that's not on this list is a weak base. All right, so the first one I see here is a common name, and it's probably the only one that you'll need to memorize. NH3 has a common name. It's so old that there was just a name for it, and it's ammonia. Ammonia, you'll smell it in cleaners. Windex has ammonia, and it smells really strong and sharp. So NH3 is ammonia. All right. The next one they have is potassium chlorate. Okay, chlorate, remember, is a polyatomic ion. Potassium is in group 1, so it's a charge 2. So this one is going to be ionic. So potassium chlorate, how would you make it? So potassium is K. In my mind, I know it's +1 because it's in group 1. Chlorate is ClO3. And it's -1. Okay, all the all the chlorates, chlorites, hypochlorites, and perchlorites, all of them are -1. So potassium chlorate, barium hydroxide. Barium, Ba, it's +2, so hydroxide's -1, so I'm going to need 2 of these. All right. So what about this one? This is C2H3O2. It was one of the polyatomic ions. It was the long one. C2H3O2 is acetate. Okay, acetate. And so if you're going to do hydrogen acetate, you would have to name it with its acid name. So this is acetic. Okay, because it's 8 goes with ic. So acetate goes to ic, and then this would be acid. So this is acetic acid. All right, so let's go back up to ammonia and find out if it's ionic or molecular. Well, ions is both sides of the periodic table, metals, nonmetals. So this one is nonmetal, 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 all nonmetals. So that's going to be molecular. Is it acidic? Is it an acid or a base? Well, it's definitely not a strong acid, okay, and it's definitely not a strong base. So it's either a weak acid or a weak base. Does it have an H to give? Well, some would say yes, because there's H's here, so H's could possibly be given. Many times you're going to see an acid written with its acidic hydrogen in front. See, there are more than one hydrogen, but the one that can be donated is this hydrogen, so it would be out front. This NH3, though it in some ways can be used as an acid in some cases, is a base. This will, if you were to accept a hydrogen, it would be NH4, which is ammonium. You know that as a polyatomic ion. So this is going to be not a strong acid, not a strong base, not a weak acid, so it's going to be a weak base. Okay, a weak base. Next one, potassium chlorate. Well, is it an acid? No. Is it a base? Well, we know it's not a strong base. I don't know. I'm going to say I don't know. Actually, I do know, but I'm going to say I don't know. I'm just going to say I have no idea if it's an acid or a base. Okay, because there's no way for me to know. There's no hydroxide here. There's no hydrogen here. So I don't know if it would be used as an acid or a base. It won't, but I don't know that. So what about, is it ionic or molecular? Well, it's got a positive and a negative. It's got a +1 and a -1, so this is ionic. This is the other kind of substance. You can take all substances and take it into as an acid, divide them into acids, bases, and salts. And this is called a salt. All right, it's not an acid or a base, it's a salt. And salts are often these ionic bonds. And here's one, Ba and OH. Now this is ionic because this is +2 and this is 2 -1, so it's ionic. But it is on the list of strong bases. Barium hydroxide is a strong base. So this will be a strong base. Well, what about the last one? It's written as acetic acid. There's obviously an H to give. Acetic acid is not a strong acid, or it would be on this list. So it's definitely a weak acid. Is it molecular or ionic? Well, I've got nonmetal, 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 nonmetal. Everything is nonmetals, so it's molecular. Okay, and so just little by little, you'll get this.